Number 36. The table shows the body temperature in degrees Celsius of a desert spiny lizard at various air temperatures in degrees Celsius. Tell whether the data can be modeled by a linear function, an exponential function, an absolute value function, or a quadratic function, and then explain your reasoning. Alrighty, so let's just kind of take a peek here what's going on. It looks like as the air temperature is going up, the body temperature is also going up. We just need to decide which one of these would go. Is it going up at a constant? That would be a linear. So if I subtracted those, is it a constant rate? To get from 33 to 33.44 to 33.78, I would have to add 0.34. To get from 33.78 to 34.12, I'd also have to add 0.34. 34.12 to 34.46 is also 0.34, and 0.46 to 0.8 is also 0.34. So there is a constant first difference. So this is going to be linear, and I'm just going to say constant first difference. Or I could say the body temperature is going up at a constant rate of 0.34 every second, something like that. Okay, number 37. The pesticide DDT was widely used until it was banned because it's toxic to a wide range of animals and aquatic life and is suspected to cause cancer. DDT takes a long time to disintegrate after it is sprayed. The chart below shows the amount of 100 grams of DDT remaining in the environment after a certain number of years. So notice after 1 year it's 50, and then up to 6 it's 1.5625. So again, does a linear, exponential, absolute value, or quadratic function best model the situation? I notice on this one we are going down, and it's going down quite rapidly, so I'm guessing it's going to be exponential, but let's just find that out. If I divide by 2, I'll get 0.5. Excuse me, if I divide backwards, I get 0.5. Divide backwards, 0.5. Divide backwards, 0.5. Divide backwards, 0.5. So it is definitely exponential. And we could say, I'm going to say there's a constant multiplier of 0.5. So it's decaying, it's getting cut in half every time, if you wanted to say that. Or we could say growth rate is 1/2, something like that. Okay, number 38. During a halftime show, a baton twirler releases her baton into the air. The path it follows is shown in the table below. So we can see from this table, the baton is going up, and then after this 48, so it's the baton is going up, and then it's going back down. So tell whether the data can be modeled by a linear function, an exponential function, absolute value, or quadratic. We can automatically cross off linear and exponential because we are going up and then back down. So we just need to decide, is it absolute value or quadratic? So I'm going to do some subtracting. To get from 21 to 36, that would be 15, 9, 3, -3, -9, -15. Okay, so it's not absolute value, which means it must be quadratic. So if I subtract again, I'm going to get -6, -6, -6, -6, -6. So I did get a constant second difference. So this is quadratic, and I'm just going to say it's because I got a constant second difference. Ooh. Okay. Number 39, which function family is represented by the situation below? Explain your reason. When the science experiment began, there were 8 fruit flies in the petri dish. The population of flies triples every day. So if something is tripling, we have a constant growth rate, and that's going to make it exponential. And I'm just going to say on this one, it would be a constant multiplier of 3. Okay, number 40, which function family is represented by the situation below? And once again, explain your reasoning. A shipping company charges $10 per package plus $5 a pound. So we're starting at 10, but it's going to keep going up at that constant rate of $5 per pound. So we'd have 10, then 15, then 20, then 25, then 30. So I'm going up by a constant rate. So this is going to be linear. And I'm just going to say increasing at a constant rate. And I'll even say of 5. We could say first differences would be 5 if you did that one as well. Right, number 41, a family buys a house for $150,000. The value of the house increases 5% each year. Write an exponential function to model the situation. So this one gave us a hint that we want an exponential model. So we're going to write y equals a times b to the x. My a is what I started with, and I'm starting at 150,000. And then remember, my b is my growth rate. If I increase by 5% each year, first of all, 5% as a decimal would be 0.05. And if I want to increase, we're going to be adding 1 to that. So we'll have 1 plus 0.05, which will be 1.05, and it's going to be raised to the x power. So that is the exponential function to model the situation. Number 42 says to use your equation from 41 to find the value of the house after 10 years. So now we're going to take that equation and we're going to put 10 in place of the x, and if you type that into your calculator, you're going to get $244,344 as your answer for that one. Okay, number 43, the equation of an object's height that was launched into the air is given by this formula, where s is in meters. How high is the object 4 seconds after launching? Well, 4 seconds would be a time, which means I'm going to, wherever I see a t in this equation, I'm going to put 4. So we're going to put negative 4.9 times 4 squared plus 19.6 times 4 plus 58.8, and then we just need to figure that out. And let me go get my calculator so I can figure it out. So let's see. Negative 4.9 times 4 squared plus 19.6 times 4 plus 58.8. I got 58.8. All right, so it is 50. Is it going to let me write? No, it's not. Well, there we go. 58.8, and it said how high, and it looks like we are measuring in meters, so it will be 58.8 meters. So it looks like it just reached the top of that. Alrighty, number 44. Kara used a linear model, y equals 20,000 plus 0.3x, to predict her total salary from achieved total sales of x. What will Kara's salary be if she sells $50,000 of her company's products? So this is telling her how much she's selling, so that must be our x. So we're going to have y equals 20,000 plus 0.3 times the x, and the x in this case is 50,000. So again, we'll plug that in our calculator. 20,000 plus 0.3 times 50,000. That is 35. Once again, it doesn't want me to write. $35,000, and it doesn't look like I'm going to write. Well, there we go. Okay. $35,000 would be her salary.